Okay, so we drew that diagram using the point that they gave us, then we put in our right angle triangle. All right, we remember that the x coordinate is the x length, but because it is on the negative side of the x axis, we have to put in negative 12 there. All right, that's very important. Then the y coordinate is the y length, the length along the y axis, so that was 5. And then we could use that to calculate our R or OP, as we call it here, because it's from the origin to point P, using Pythagoras, right? I think we did this one in class together, finding that OP is 13 units. And I still say that since it is a Pythagoras, you can just write OP equals 13 Pythagoras straight away. You don't actually have to throw that word in there. All right, then I asked you guys to calculate the values of the 6 trig ratios with alpha for homework. And I say, just trust me on the fact that you can use the acute angle, even though alpha is that obtuse angle there. Okay, we are going to do a note on that now, on why we can actually use that acute angle, even though alpha is the entire obtuse angle. All right, so when it's asking for sine of alpha, we use the acute angle, sine is opposite over hypotenuse. Right? Cos is adjacent over hypotenuse. Tan is opposite over adjacent. All right, so you're just using the 3 sides of the triangle to get your 6 trig ratios. We're going to do the other ones now. Cosec, we know is the reciprocal of sine. So if sine is 5 over 13, cosec is going to be 13 over 5. Sec is the reciprocal of cos. So if cos is negative 12 over 13, then sec is going to be negative 13 over 12. You can swap them out. And the same thing for cot. If tan is negative 5 over 12, then cot is going to be negative 12 over 5. You can now the simplest form is the same line off because we're doing a positive number divided by negative. So I'll go right with the minus in front. So guys, when we started doing, or at the top of this exact page, actually we did the cost diagram. You guys remember where I told you that certain trig ratios are positive in certain quadrants. All right, I just want to go back up to that now quickly. I'll move that down again. So we said here that all the trig ratios are positive in the first quadrant, and we actually can see that we didn't work with numerical values here, but when we were working in the first quadrant here, all the trig ratios were positive, right? Now, in the second quadrant, which is what we have a triangle in, all right, in this example, in the second quadrant, only sine is supposed to be positive, and the reciprocal of sine. And when we actually calculated or sides there, ratios, then we could see that, right? Sine is positive, but cos and tan are both negative. And guys, that is because of this side here being negative 12. All right, so all the trig ratios that work or that use this negative 12 is going to be a negative R. Okay, so sine doesn't work with that negative 12 because sine is opposite over hypotenuse. It works with the positive 1. But tan works with the negative 1 and cos also with the negative 1. And that's why those trig ratios are negative. So you can't use like it's one's all positive, then you can't use tan for positive. Yeah, no, never mind. Okay, I just want to do a little note on why we are allowed to use this angle when we're finding the trig ratios, even though it's asking for the trig ratios of the obtuse angle. All right, so that is on the next page. So I just did a little heading. Why can we use, so annoying this light. I have always made this thing. I did, that's what the start comes in.
Don't meant like you sine.
Now, the time the value of the angle. Value of the ratio is that ratio. So you only do that if they ask you to find the angle. You might, yeah, but that's not what it says. I just feel like this light was on here previously. No, it wasn't. No, I never had it on. No, if it's on, then it's even worse. Okay, strange. I just have to work around it. Okay, now guys, we will draw a little diagram, but I first just want us to get our calculators out. I'm just going to do some calculator work quickly. Actually, maybe we should do them at the same time. Okay, I'm going to draw a Cartesian plane. We do want to draw triangles now in each of the 4 quadrants. Okay, so let's draw the quadrants so that they're all big enough for us to actually draw triangles in. Okay, and guys, we are going to draw a triangle with a 30-degree angle. All right, so you can just try and, yeah, it doesn't have to be to scale. Okay, we're just going to draw a triangle. I'm sure that's probably a 45. Okay, let's do it kind of more like that. Probably not accurate, but anyway, it doesn't really matter. And guys, what we're then going to do is we're going to draw the same triangle in all 4 quadrants. Okay, so we're going to draw the same 30-degree kind of line in the 2nd quadrant, and then in the 3rd quadrant, and then in the 4th quadrant. Okay, we want to draw the exact same triangle in all 4 quadrants. It's up to you. You can decide. Oh, I did mine 8.8. Everything is on. Yeah. Just to get them to look. That's a good idea. But I'm still gonna do that. Yes, that's better than mine. Don't have to try. Nothing away from that.
I'm sure.
Well, for you, there's those little dots which you can, like a dot. Yeah, but it's, I know that, it's just so much. Well, I am, yes, but then it just is in the same orientation. These ones are all in different ways.
I mean,
Yeah, I'm sure they
you just control down the two dots on each one, then you have the angle.
But yeah, I think this is probably, maybe I'm just being typical, you guys can tell me now. Okay, I think I got it. So that kind of thing, right? That's what you want, yeah? That's exactly the same.
That's pretty good, I think.
Thank you, I tried. Okay, now guys, if we have 50-degree angles and 90-degree angles, what are the other angles in all four of those triangles going to be? 60. Hey, remember the three angles in the triangle add up to 180. So we can use that to calculate all of those top angles. So those will all be 60 degrees. All right, guys, now we are actually going to use our calculator to fill in the lengths of these sides, right? Because this is an actual proper triangle, not with x's and y's and so on. We have angles in it. Let's calculate what sine of 30 is. Because remember, what is sine? Sine is opposite over hypotenuse. So if I can see what sine 30 is equal to, yes, it's 1/2, right? If you type that into the calculator, you will get that sine 30 is 1/2. Now I'm just going to write that on the side here. Sine of 30 degrees is equal to 1/2. And we know that sine is opposite over hypotenuse. So if we have a triangle with a 30-degree angle in it, then, and we know that sine 30 is 1/2, then the opposite side to the 30-degree angle is going to be 1, right? It will have a length of 1 then. And the hypotenuse will have a length of 2. Now guys, we did the same triangle in all four of the quadrants, right? Congruent triangles, identical triangles. So that means that all of those lengths must be the same, right? So here, that hypotenuse is going to be 2, that hypotenuse is going to be 2, that hypotenuse is going to be. Yes? Remember, the hypotenuse is always positive. Okay, but the others are going to be negative. Yes, you are on the right track. Guys, here, if we're looking at this length, is this going to be positive 1 or negative 1? Positive 1. Hey, we're looking at the y, and it's on the positive side of the y-axis. So this one is going to be positive 1. If we are in the third quadrant, that length is still going to be 1, but because it's now on the negative side of the y-axis, we need to fill in negative 1 on our triangle. And what about the fourth quadrant triangle? What is the y length going to be here? Negative 1 as well. Okay, any questions? Okay. Now, guys, we can use our 1 and 2, right, those two lengths, to find the third side of this triangle using Pythagoras. So let's do that quickly. Let's call this length x because it is the x length, okay? So x squared is going to be, now guys, is x the hypotenuse? No. No. So when we're finding this side, we're going to take the hypotenuse squared minus the other one, all right? So we're going to say 2 squared minus 1 squared. And then we are supposed to write Pythagoras. So we'll just move this across. Right, so that is 4 minus 1, which is 3, right? So x squared is 3. So x is going to be √3 units. So I'm going to fill that in blue because that is the one that we calculated. So this is root 3, that length, all right, in both triangles, the same length there, root 3. What is it going to be on the other side when we're in quadrants 2 and 3? Negative 3, so negative root 3, right? Because here we are now working on the negative side of the x-axis. Let me just do it in a bit. So this here is negative root 3 in both of these triangles. Because we are finding one of the sides that's not the hypotenuse. And we always have to take the hypotenuse squared minus the other one. Okay, now guys, the idea that I'm trying to get across here, remember we're trying to figure out why, when they've given us this big angle here, why are we allowed to work with the acute angle, right? Now guys, if they've given us this entire angle here, what would the side of that angle, of that angle be? If we're going from the positive x-axis to that line. Okay, can we see that that would be 150 degrees? How do I get that? 180 minus that acute angle, right? If I'm trying to get this blue angle here, which is what we had in the example yesterday. We had an angle in the second part, okay? Now guys, if you are calculating sine of 150, and we're actually going to use the calculator for this now so that we can see what we get. If we are calculating, sorry, let's put a 150 degrees in there, right? Because we're going to be working with that. Oh dear, sorry. Sorry. Okay, 150 degrees. I'm going to burst into song here, isn't it? All right, so now if we are calculating sine 150, I will type that into the calculator. 1/2. That's interesting that we're getting the same exact answer as for sine 30. Right, we're getting 1/2. Let's quickly calculate cos of 30 and then cos of 150 and see what happens. All right, so cos of 30 I'm going to do in black. Cos 30, we can just use the calculator or we can use the triangle, right, if we want to. Cos of 30 is root 3/2. Okay, so that approximates, but we can use the calculator if we want to. Cos 30, root 3/2. All right, cos of 30 is root 3/2. But then cos of 150, all right, so if we're working with the acute angle, cos of 150, we're just comparing them, guys. We're comparing the two quadrants. Negative root 3/2. So the same value, but a negative answer. Okay, so I'm sure we believe what the calculator tells us, right? So the calculator is saying that cos 150 is negative root 3/2. But guys, that is what we will actually get if we're working in this triangle and we're working with this acute angle. We're using the acute angle. We're saying that cos is adjacent negative root 3 over hypotenuse 2. Okay, now that will actually always happen. If you have the same exact triangles in these quadrants, you will always get the same values for those angles, but the signs will be different depending on which quadrant it's in. Okay, we can do some more quadrants. We can see what happens in the other ones. What would this angle be from 0 all the way around to that line? What would that angle be? So it's 180 to there, but then we're adding another 30 to it. Okay, 210 degrees. You guys see what I'm doing? We're going from 0 all the way around to that line in the third quadrant. That will give us an angle of 210 degrees because it's 180 plus 30 there. Okay, it's going to look a bit busy now, but I think I do just want to pull that in. Let's use red. Okay, if I'm going to go all the way around from 0 to that line, that is 210 degrees, right? I just want to make sure that everyone knows where that's coming from. Okay, from 0 to 180, that straight line there. And then you're adding a 30-degree angle.
So the blue sign one
Yeah,
was for the.
yeah, 150 degrees is in the second one.
But in the first line, the project was what?
They are equal to each other because it's positive and opposite over hypothesis. You get a half for each. All right, let's look at this red one with you guys. I'm again going to do one in black. I'm going to do sine. Oh, we already have sine 30, right? We know that sine 30 is 1 over 2. Let's quickly do sine of 210 on the calculator. Sine of 210. Sine 210, sine 210, sine 210 degrees is negative a half. So again, the same value, guys, but now a negative answer. Why? Because we now have a negative opposite side. All right, just look at the board quickly. If we're working with this angle and we're saying opposite is negative 1, and our hypotenuse is 2, we will get negative 1 over 2. Okay. So guys, you don't have to stress about this too much. What I'm basically just trying to show you is that when you are working with a triangle in any quadrant, all right, we're never actually going to work with a triangle in all 4 quadrants like this. All right, you'll see now when we do another example. When you're working with a triangle in any quadrant, you will calculate the angle or the trig ratio of the angle from 0 to whatever that line is, but you can work with the angle in the triangle. Okay, so when you're doing your opposite and your hypotenuse and your adjacent, you look at the acute angle inside that triangle, like we did in the example from Friday, like we did over here. Right? We were working with alpha, which is an acute angle, it's an angle in the second quadrant, but when we found our trig ratios, we looked at the inner angle. Okay, the reason for that is because we will get the same answer, the signs will just be different. Okay, so we can look at this angle, do our opposite, our hypotenuse, and our adjacent. So we're going to work with that stuff quite a lot in grade 11. In grade 10, all you need to know is just that you can use this angle in the triangle. Okay, so if you're not 100% convinced, don't panic. We are going to practice it now. Yes, Jonathan. All right, so let's do another example, guys. Have you all copied this down?
I have.
I'm sorry. All right, guys, you can just write example again. We're going to do another one together. Now we've done this. And then guys are going to practice on yours. Yeah.
Why is the one connected?
Because if you're looking at the 30-degree angle, all of these sides are pointed to. Yeah, that's it. Anyone else have great buddy? Yeah, thank you, Christina. I always forget about that. Put your hand up and Christina will come to later.
You know?
But in the first quadrant, all the sides are positive. But with all the triggers. No, because 50 is not actually an angle. 150 is in the same angle. But you are looking at this angle when you are finding your opposite and your hypotenuse and your adjacent.
No, I've just kind of realized this is a smallest question or but like say we didn't have so there was for some reason we couldn't use the acute angle. Could we use the like all around angle to get our sides? Like
You will always have to use the acute angle because it's an angle in the triangle.
then that's fine, but yeah, I was just like wondering if there was an exception.
Always have to use that angle. Guys, let's just do another example quickly and then maybe you'll feel a bit better about it. Let's see. Let me just go to this page, 109. Okay, example. We've done one, we're doing another one. P is the point. X and negative 15. in the third quadrant. And OP is equal to 17 units. Yes. In the first question, they are wanting us to calculate the value of x. Yes, guys, you're going to have to draw your Cartesian plates. Notice that they are telling you that this is in the third quadrant. You don't still have to figure out which quadrant this is in this point. I'm going to do another. So they're telling you that x is the x coordinate of the point. See along the window, there's a bit much passing around. You left us over here, now you. All right, so x negative 15. They've given us the y value. Note that it's a negative value because it's in the third quadrant. So in your triangle, you're gonna have to write negative 15. All right, and they've given you the length of the hypotenuse, which is always positive, which is 17. Please draw your Cartesian plane, put your triangle in the third quadrant, and calculate x. If you can do that on your own, yes. So in the next question, we are going to have to use it because they're going to ask us to find ratio. So it's better to just actually do it. Yeah, so you just can do it wherever, as long as it's in the third quadrant. You're not going to plot negative 15 to scale anyway. Just anywhere in the third quadrant.
Value of x.
I haven't calculated it. I'm going to show you my picture. That's what it looks like. It doesn't have to look exactly like this, so you're going to be anyway. Next, but I mean, we're not drawing it to scale. We also don't know what x is yet. We do know that that is the point x negative 15. So guys, if the y value is negative 15, then this is going to be negative 15, right? The length along the y-axis. They told us that OP is 17 units. So we use that to set up our right angle triangle and we can calculate x. Okay, so this would be x. You don't have to write x there, but that would be the length that we calculate. Yes.
I did it. I'm not calculating. I got the answer, but it's not a negative.
So yeah, it won't come out as a negative.
So we must be negative.
So guys, we're doing x squared. Again, it's not the hypotenuse that we're finding. So we have to take the hypotenuse squared minus the other one squared. So we have to say 17 squared minus. Now for this, I said the other day, you can either use negative 15 and square it, or you can just use 15 squared if you want. It's not going to make a difference to your answer. All right, when you square a positive number or a negative number, it is positive either way. Then you need to write Pythagoras. There we go. What is the answer to x here, guys?
Negative 8.
Okay, now what's x squared? Did someone calculate that?
64.
Is it 64? Okay. So let me just show you here. You don't have to write it like this, but x squared is going to be 64. All right. Now, guys, usually when we're finding x in an equation like this in Pythagoras, right? When we're using Pythagoras, because we're finding the side of a triangle, we just say that it's the positive end. All right, because we know that the side of a triangle is always positive, the length of the side. But the actual way in which you need to solve for x in this type of equation, right? If it wasn't in the context of a triangle or Pythag, you would actually say that x is plus or minus the square root of 64. Do you remember that? When you're taking a square over that and turning it into a square root, technically you are supposed to do plus or minus square root. right? Because when you say 8 squared, the answer is 64. But if you say negative 8 squared, the answer is also 64. So positive 8 and negative 8 are actually possible answers for that equation. Usually when we do Python, we don't say plus or minus 8 because we know it can just be positive 8. But now in this case, guys, it's actually going to be negative 8. Alright? So here, I would suggest writing it like this, saying that x is positive or negative 8, but we are working in quadrant 3, so you can just write Q3 like that. Therefore, x has to be negative 8. Okay, so then we can pull that in on our picture. We know that x is negative 8.
You have to write x.
I can say you can have the date of the right stuff actually. Okay, now guys, I forgot to write in the heading what the angle is. Sorry, I don't know if you still have space to fill that in. Otherwise, we can just fill it in on the diagram as well. The angle that they've given us here, this is just from the textbook. They're saying that beta, I don't know, have we worked with beta yet? No. All right, so they're saying beta is the angle between OP and the positive x-axis. So this angle here, you have to indicate it as that angle, right? That is important. Even though we use the acute angle in the triangle, you have to show that the whole angle is beta, and beta is like a B with a tail. Kind of thing. That's what it looks like. But guys, if they're giving you the picture, which they will do in the questions that you're going to do, they actually show that on the picture. Okay, they indicate that angle. But like we just saw in the example at the top, when they are now asking us to find trig ratios here, we are going to look at that angle there. All right, we're going to say that from this angle, that is opposite, that is adjacent, that is hypotenuse. No, you can actually use this. So that will give you the same answer. Just give us this, not the actual degree. So this is the actual angle that we're working with, but you just look at that angle. Because I mean, guys, you can't find an opposite angle to this whole big, or an opposite side to this big angle. Right? No, that's why we just work with the but I know I'm going to say that. Oh, yes, yeah, we just give off these very often. Okay, guys, so for B, question B now, we find that they can't find the value of x. Yes, all right. For B, they are now asking us to calculate cot beta plus cosec beta.
They got beta and I got black and they got 40. And then the same ratio.
They will have the same ratio. Yes, so beta will just have the same. Okay, guys, so cot beta, right? What is cot again? Cot is the reciprocal of tan. It's easier to remember that tan is opposite over adjacent, so cot is then adjacent over opposite. Thank you. So I'm actually not going to write them separately. I'm going to do it all in one line. Okay, so cot beta plus cosec beta. All right, we said now that cot is adjacent over opposite. Okay, tan is opposite over adjacent. So then for cot, you just swap them around. So we're going to say opposite. No, sorry. Adjacent over opposite. So negative 8 over negative 15. You don't have to show those negatives. You can actually cancel them out right from the start if you want. I'm just going to write it out for you. Okay, so cot is adjacent over opposite, the reciprocal of tan, plus cosec is the reciprocal of which one? Sine. Sine. Remember we look at the third vector, right? Cosec is the reciprocal of sine. What is sine again? Opposite over hypotenuse. So cosec is going to be hypotenuse over opposite. So we're looking at hypotenuse 17 over opposite negative 15. So we
Do we not have to go 1 over and over?
That's actually longer, you can just do it like. Okay. Right, guys, let's just quickly simplify this and then add them together. Do we agree that this is 8 over 15? 17, thank you. Do we agree that this is 8 over 15 minus 17 over 15? Are we fine with that?
Yeah. Right.
Plus and negative. 17 over negative 15. And guys, they have the same denominators, right? That's quite nice. So I can just do that from the start. What's 8 minus 17? Negative 9. Is this simplest form? 3 goes into both of those, right? 3 goes into 9 3 times and into 15. You're not stupid, you just made a mistake. Here we go, negative 3 over 5. And guys, they didn't specify in this question that going forward and in grade 11 and grade 12 and in your final exams, you will have to do these questions without using a calculator. All right, so you will have to actually show all of those steps. If you're having to simplify fractions and so on, you do need to show that without using a calculator. So even if it doesn't say that in this exercise I'm going to give you now, let's practice doing it without using a calculator. Okay. Any questions on this one, guys? I think once you're actually practicing it on your own, you'll see that it isn't really that bad. Okay, it's not actually very good. Not the angle, it's the ratio of sides. The angle is, no, you're not. You're calculating cos of and cosec of theta. Those are ratios of the sides in relation to beta. Not actually beta. Okay, I would like you to do numbers. Let's do 2. And guys, in all of these, they have already drawn the diagrams for you. You just need to fill in the sides and then do the calculations. So it's not going to take as long as the one that we just did. Number 2, 3, and 6. Okay, you're going to start working on that now, please. We still have 15 minutes.